Lesson 33, Infinite Geometric Series. The series never ends. All right, so let's talk about the difference between divergent and convergent infinite series. So one of them has a sum we can find, and the other one has a sum that's undefined. For the following series, find S2, S3, S4, S5, S6. So let's do that. So with this series here, we've got first S2 would just be 1 plus a third. And this might be easier to write as a decimal instead of a fraction. So it'd be 4 thirds, but it would, as a decimal, it'd be 1.33, repeated. So now if we go S3, that's going to be 1 plus a third plus a ninth. So we get 1.44 S4. So 1 plus a third plus a ninth plus 27th. 1.48. And I'll just leave the decimals. And then S5. Well, I'm actually just going to leave that there. Kind of starting to see the points here now, right? You can see that the numbers are getting, the difference between the sums here are all getting less and less and less. And if you were going to graph that, make like a quick sketch of something like we have here. If we had like n along the x-axis and then our sum along the y-axis, what this would look like, so if this was like 1 here and then 2 up here, and then our n values be like n1, 2, 3, all the way up like that, what we'd start to see is that this thing would start to flatten out like that. It's converging. It's converging on a single point. The higher up you went with this, the closer these numbers would get. They all of a sudden just be like, like really close together. They're getting really close to this red line here. That's an asymptote on a graph, and it means it's converging at a single number that we can figure out. We can figure out what the sum of that is, like as it starts to get really close to that line. So that's what I mean by converging. So now if we look at this one, so if we add 1 plus 3, so S2 would be 4. And then S3, we've got 1 plus 3 plus 9. So we got 13. And then S4, 1 plus 3 plus 9 plus 27. So that's going to be 40. So now you can start to see what this graph would look like if you were going to graph this thing with n on the x and then like the sum going up on the y. Then this type of graph, if this was 1, this is like n's equal to 1, n's equal to 2, n's equal to 3. This thing doesn't go towards some kind of a line. This one would start at 1, and it would end up going like this, and goes on up forever. So if this one over here was converging on that red line, you can kind of think about this one as diverging or going astray or going a different direction from that red line. It's leaving, right? It's going away from any kind of like number that we can put our finger on. I don't know if you guys have seen like the Divergent series, but that's kind of what the name comes from. Divergent just means to like go away. So divergent means to like leave the normal. That's why that the people in that movie are like, divergent. They're kind of like going against the norm there. Convergent would mean that they are, being the same as everybody else. They're all converging on a single point. All right, so that's kind of what we mean by convergent and divergent. So this divergent situation over here, we can't do anything with that yet. That's a calculus type of a problem if you were going to figure out, up to a certain point. Actually, I guess we could with it in a lot of ways, but we're not going to deal with that with the infinite series. Convergent, we can figure out what the sum is if you added all these things up as it started to approach that line. So that's where we're going to go next is convergent infinite series. So they're going to be ones like this where it's like, 1 and then a smaller number, smaller number, smaller number. So they converge on the single point. All right. So now, if we start off with the formula that we had in the last lesson there, and I'm just going to write it over here. So Sn is equal to Rtn minus 1 over R minus 1. And now if we think about this, if we had the sum of an infinite series, so I'm going to say like an infinity sign there, and then R times, now if it was t to the n, we'll kind of look what happened with our conversion series over here. These numbers got smaller and smaller and smaller and smaller all the way, right? So if I went infinitely this way, then the numbers I'm dealing with are going to be infinitely small. They're going to be, you could say 0, right? So if my series went to infinity, then the final number there I could say was 0, which is kind of a weird, once you start thinking about infinities, it's kind of hurts the brain, but that's what our number would be, right? They're getting like infinitely small as they get to that point. So it's going to be that minus 1, and then over R minus 1. Not 1. Thought that looked wrong. T1. Sorry about that. And then T1. So that's what we got, and then over 1. Okay, so now that we've got that, let's clean this up. This part of the equation is just equal to 0, so it's kind of gone. So I can say the sum of the infinite series is going to be equal to negative T1 over R minus 1. Now, this is the equation, but this one just looks a little bit nicer. We just get rid of some negative symbols there. And the way we can get rid of those negative symbols there is if we multiply the top and bottom of this thing by negative 1. So if we multiply the top and bottom by negative 1, what we'd end up with is S infinity would be equal to T1 over, now negative 1 times R is negative R. Negative 1 times 1 is 1. So we'd have 1 minus R. So you can see that this is this formula. So that's how we got that. And that was all by making Tn equal to 0. So now let's add up this infinite series, this infinite converging series. So we know T1 is 12. We know R would be 1 over 4, right? To go from 3 to 12, you'd have to divide by 1 over 4. Or you can think about, going 12 divided by 4 to get to 3. However you want to think about that to get to that R value of 1 over 4. Okay, so we got that. Now we just need to plug it in. So our formula is S infinity. T1 was 12 over 1 minus a quarter. And you should get 16. Okay, now let's decide whether these are going to be convergent or divergent series. So state the sum if the series exists. So if we look at this one, you can see that we've got T1 is equal to 1. R would be negative 1/3, because I could go 1/9 divided by negative 1/3 to get to that, and go negative 1/3 divided by negative 1/3 to get to 1. So that's how we figure out R. So now if we put this in, we will actually get a number for it. So S infinity is going to be T1 was 1 over 1 minus a third. It's really 1 plus a third. So we'd end up with here, we got 1 over 4 thirds, which if you rewrote this, right, we're dividing by 4 over 3. That's the same thing as going 1 multiplied by 3 over 4. 1 over 1, I guess you could say. So then that's just 3 over 4. So 3 over 4 is what that would look like. So we did get a sum out of that, right? And you can see because these, as they go on, are getting smaller and smaller and smaller. Tn, the way you can tell here is that Tn would equal 0 if you went far enough along with this, right? It's getting smaller and smaller and smaller and smaller as it goes. So if you went to infinity, Tn would be equal to 0. But now let's look at this one. So we've got 2, 4, 8. The next one would be 16. Then it would be 32 and then 64. And you can see that these numbers are getting bigger and bigger and bigger. So Tn here would be equal to infinity, right? They're going to get bigger and bigger and bigger. So this doesn't work. I can't have Tn being infinity. Like what this would sketch out to would be like, diverging away, right? So we can't really do that. So no, there's no answer for this one. Okay, last one. Okay, so it says in the diagram, assume each shaded square represents a quarter of the area of the larger square. Bordering, I should say 2. TWO. Of its adjacent sides, and that the shading continues indefinitely in the indicated matter. So A says write the series for the shaded area. So what we have here, the first one, this shaded area, you could say, well, that's a quarter. So start out with that. What's this area going to be? Well, that's a quarter of a quarter, right? Because this was a quarter, right? That one there. So we got a quarter of a quarter. So if you want to figure out what a quarter of a quarter was, you go a quarter. We're just kind of figuring out what percentage of a quarter, the percentage of a quarter. So I just go 1 over 4 times 1 over 4. That's 1 over 16. So that's what that's going to be. And then the next one would be a quarter of that. So I'd go 1/4 times 1 over 16. So that's 1 over 64. So I can start to see how this is going up, right? So it's going to be plus. The first one was 1 over 16. That gave me that part. And then the next one would be plus 1 over 64. Plus, and now you can see I'm really just multiplying the denominator by 4 every time. So 1 over 256. So really small numbers that we're getting here, right? We're going to be converging at some different point because, the next one would be there. And then, it keeps on going smaller and smaller and smaller. Okay, so go plus dot dot dot. So now let's use our new formula. So S infinity is going to be equal to T1 over 1 minus R. So we know T1. Let's write it maybe over here. So T1 was 1 over 4. R. So our R value was 1 over 4 as well. Okay, so as we fill this in, we're going to have S infinity. It's going to be 1 over 4. You might want to put in brackets. Over 1 minus 1 over 4. So I'm going to write this out as 1 over 4 still. And I'm going to write the bottom as 4 over 4 minus 1 over 4. So now we can subtract those. Just maybe doing too many steps here for you, I don't know. Minus 1 over 4, or sorry, is equal to 1 over 4. And then on the bottom, we've got 4 over 4 minus 1 over 4. So it's going to be 3 over 4. Maybe put those like that too to help to get or to not be confused about what's happening there. So now, like I was saying, we've got a fraction divided by another fraction. That's the same as multiplying by the bottom flipped. So this is going to be the same thing as 1 over 4 times 4 over 3. So now we can see that 4 will cancel with 4. This is just going to be equal to 1 over 3. Okay, so here are the practice the problems I'd like you guys to do next. And whoop, you guys already did this one. That probably looked like a lot, eh? So it's just these questions. So on page 63. So 1, 2, 4, and then 5, 6, 7, 8, 9, 10. So those ones. Okay, so I'm going to end that video there.